Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we're going to add a switch mode power supply into the chest plate of Fred. One of the things I've noticed is the Raspberry Pi that's actually powering this small microcontroller is struggling with a lack of available power. It's causing voltage drops. And while it's still working, it's not good. So what I'm going to do is give it its own power supply running on the same controller power as the other two Raspberry Pis we've already installed. I'm going to use this XL4005 DC-DC buck converter to drop the 20 volt DC down to the 5 volt we need for the Arduino, and also connect up pins to power this NeoPixel ring setup. Now this is two different NeoPixels just wired in series. When I say wired in series, the power is paralleled across, but the data carries from one to the other. So it just adds to the total number of NeoPixels. This can then feed up through the torso of the robot in order to plug into this board and allow us to have a nice pretty light display. But these things can draw quite a significant amount of power, and there is no way I can power this off the Raspberry Pi when the Raspberry Pi is already struggling for power. So let's get this one mounted in and the fly leads off ready, and then we'll pull this out and get it a set of headers so we can actually connect this up. So let's get started. Okay, so anyone who's followed my channel for a while will know that before you plug a microcontroller in with a small switch mode power supply, you always test and set the voltage first. Now this is one I've previously set the voltage on to 5 volt, but always make sure you check it just to be on the safe side before you put your 5 volt microcontroller in there, or you will discover it emits a large amount of smoke. So this board's basically all built up, ready to go. I can now mount it back into the robot, plug the USB cable back in, and this cable can be plugged in to here and is connected to pin D7, I think it is. So when we configure the NeoPixel service in MyRobotLab, we tell it to use that Arduino and we tell it to use pin 7. So yeah, it's working, but it needs to be connected to a Raspberry Pi to drive it, or a PC to drive it, so that it has its signal to drive the NeoPixel array. So next trick is to mount it back in the chest. Mount this back in the chest. I'm going to use hot melt glue again. One of the major disadvantages of hot melt glue is that it's not very strong and easily breaks. And in this case, that's also the major advantage, so that when we want to make changes, we can easily break the glue and pull it off so we can make our changes and then glue it back on. So I'll do that, and the next thing will be to test it with some code. Okay, to do the final connection, I'm going to have to power everything down. I probably should have done that before, but yeah, you know how it is. Try to do it all live if you can. So I'll shut everything down now. Well, it would seem I misjudged the length of my new wires. Not by a great deal, but enough to be a pain in the neck. So what I think I might do is actually add in a heavier bit of wire from the connection to the back of the robot. with these connectors and this bit of heavier wire, and then I'll connect all of the controller wires in through those. So get onto that. Okay, so I've got power onto Fred now. I haven't powered up his servos, but all the controllers have got power on. That includes the UltraSonic and PIR controller. Now, before it was powered from a Raspberry Pi, so that was always powered with a controller. I've now got a NeoPixel ring on him as well, and it works, which is really cool. Now the NeoPixel ring, the standard NeoPixel ring that you use with an Inmoov robot is 16 LEDs or NeoPixels. I've added another 7 to the middle, so I've now got 23 NeoPixels in there. The new power supply appears to be running it quite happily. The Raspberry Pi running it is not complaining of a loss of power anymore. And I've now added that into the program for Fred, which is available for download from GitHub, but I haven't included it as part of the live functions yet, just the raw code to make it operate. To give you an idea how bright they are, you can see how bright they're looking on the camera. In a range of 0 to 255 in brightness, with 255 being the highest brightness, this is currently set at 15. If I choose to run another one that has far more brilliance set in it, you can see it just overloads the camera, but it does look in person to be very effective. So I'm going to call it quits on this video. If you like these videos, click on subscribe, like, ring that notification bell. There is a Patreon link in the description if you like to support future developments and equipment going into this sort of project. There's a Discord channel, a link in the description for that, where you can make suggestions or ask questions. And we'll see you in the next video.